Okay, let's do the second half. Now, if you see at the top of page 3, there are some rules that we can do with power series. If you've got two separate power series for two separate functions, first it talks about if you multiply x by a scalar, so instead of like 1 minus x, you had 1 minus 3x. It's just that 3x would go there in the parentheses, so that 3 would also be raised to the nth power. If instead you replaced 1 over 1 minus x with 1 over 1 minus x squared, then it would just be x squared in there, so everything would be raised to the 2n power in the end. And you can add or subtract functions. Notice that there's nothing on here about multiplication and division, which is important. Do not multiply or divide separate functions. So now you're asking yourself, then how can I do f of x equals 3x minus 1 over x squared minus 1 centered at 0? Okay, so we can't do them separately and divide. We need to have a strategy. And the strategy is going to be something we've learned before, namely 3x minus 1. If we factor the denominator, it's x minus 1 and x plus 1. You might think, well, this is 1 minus x squared like, but the numerator always needs to be a. So what we're going to do here is partial fraction decomposition. It's a over x minus 1 plus b over x plus 1, which of course means a times x plus 1 plus b times x minus 1 is equal to that 3x minus 1. So if we plug in negative 1, or if we plug in 1, b will die. So a times 2 equals 3 times 1 minus 1 means 2a equals 3 minus 1 is 2. So a is 1. Now at negative 1, you get b times negative 2 equals 3 times negative 1 minus 1. So negative 2b equals negative 3 minus 1 is negative 4. So b is 2, which means this is, in total, 1 over x minus 1 plus 2 over x plus 1. Now I can rewrite each of these in normal form. 1 over x minus 1 is negative 1 over 1 minus x, just by multiplying everything by negative 1. The second one would be a little more complicated. It's 1 plus x, which is 2 over 1 minus negative x. So what does that mean? Well, this becomes the sum from n equals 0 to infinity of negative 1 times x to the n, ar to the n. The second one becomes n equals 0 to infinity of 2 times negative x to the n. Now they're not exactly the same, but if I pulled the negative 1 to the n out, I could deal with it, but there's not really much to do. At this point, I would just leave it like this as an approximation. We could try to combine them, but the point is, I could add the terms, but I'd have to pull the negative 1 to the n out, and if I add those, it just gets complicated, so I would leave it like that. Now, notice that there's a note at the bottom of page 3 that says sometimes you have to be clever, and instead of actually just turning it into a power series, you can integrate or take the derivative, etc., of a series. So for example, find a power series for f of x equals ln x centered at 1. Instead, start example 2, which is from the last video, to start. Now we already knew from example 2 that for f of x equals 1 over x, we had come to the conclusion that this was 1 minus x to the n. I think it was 1 times 1 minus x to the n. the way we had done that is turn it into subtraction by adding and subtracting 1 and putting the 1 up front. Okay, so how does ln x compare to 1 over x? It is the integral. So I should be able to integrate this, because this is just it's a polynomial with a bunch of x's. I should be able to integrate each of these terms. So what is the integral of 1 minus x to the n? That'd be 1 minus x to the n plus 1 over n plus 1, really times the chain rule, -1. So what is that going to do for our function? It's simply going to change it to the summation from n equals 0 to infinity of -1 times, I'm really going to put over the n plus 1 here, times 1 minus x to the n plus 1. Now I could pull a -1 to the n out and deal with it, but I'm just going to leave it like this because of the way we did it the first time. So this is just an example of where we can take the integrals to find the power series of something that wasn't really in the a over 1 minus r form to begin with, but if we took the integral or derivative of something that was in that form, we could get it there. Lastly, f of x equals arctan x centered at 0. Okay, what's the derivative of arctan x? 1 over 1 plus x squared, which is equal to 1 over, so it's the integral of 1 over 1 plus x squared. It's the integral of 1 over 1 minus -x squared. Now this is a over 1 minus r form, so I need to integrate. By the way, I should say we integrated this, so what do we really need? It's this whole thing plus c back up here. The integral of the equivalent summation form, n equals 0 to infinity, of our a is 1. This is -x squared to the n. Now I'm going to separate this out into -1 to the n times x to the 2n. It's a little more clear when we integrate why we should do that. So what's the integral of this thing? Add 1 to the power and divide by it, so it should be the summation from n equals 0 to infinity of -1 to the n times x to the 2n plus 1 all over 2n plus 1 plus c, because there's going to be a constant involved in here somewhere, so we need to account for it. And this is how you use integration to find summations you couldn't otherwise find, or in this case derivatives. And that's it for 9-9.